All right, thanks for coming to my session. I'm Dan Gallo, a technical sales engineer at Accenture. I'm going to be talking today about building an Ext JS dashboard application that can be used for visualizing and interacting with IoT data. So I'm going to be talking about how we can handle data from different types of devices and sources, and how we can visualize this data to make it meaningful and also aid us in the decision-making process. So first of all, let's talk about the Internet of Things. Internet of Things has been a buzzword for the past few years, but it's only really starting to see fruition, I believe, in terms of the number of devices that have Internet connectivity. So Internet of Things is all about the linking of smart objects to the Internet, so physical objects that have an IP address, and it's all about the exchanging of data between these things and other Internet-connected systems. And IoT has been in the news a lot. So in Europe, they're building cities that are internet-enabled, so they have devices that are monitoring shipping containers, fire hydrants, and even cows, believe it or not. And Vodafone's venturing into IoT. They developed a POC swimsuit that when you stay in the sun too long, based on the UV level that's detected by the sensor inside of the swimsuit, it warns you on your mobile phone about harmful UV levels. But things can go wrong as well. Earlier this year in the news, you may have heard about PetNet. They have a device that automatically feeds your pet, so it releases some food on a scheduled basis, or when you release the shutter on your app. But unfortunately, their servers went down, so their pets went hungry, and owners weren't happy. And one that I can relate to, a man that spent 11 hours trying to make a cup of tea using his Wi-Fi-enabled kettle. And eventually he got the kettle to come back online, but then he said that they're eating dinner in the dark while his internet-enabled lights were downloading a firmware update. So making a cup of tea, a very British problem. So next, let's talk about data. There are various services available to help with integration of IoT devices and applications. These are just a small subset. So there's PubNub, there's Amazon Web Services, they have an IoT capability. There's also Azure, so Microsoft's own platform. And the idea behind these services are that they make it easier to enable devices to communicate with each other and with applications. So I'm going to be focusing on PubNub in my demonstration today, so let's talk a bit more about that. PubNub, if you haven't heard of it, is a real-time messaging service. It features 70 or more than 70 different platform SDKs. So the idea behind this is, regardless of the device that you have and regardless of the OS and coding language that's being used, there should be an SDK available that device can use in order to publish sensor information or data through to PubNub. So if we take a Node.js application as an example, there's a Node SDK. All you need to do is require the PubNub SDK, specify your unique publish key, and then you can do pubnub.publish, specify a channel, and that's just your own channel name, and that could be like a temperature channel or alarm channel. And then all you do is you specify a JSON-based object containing your data that you want to publish. So in this example, we're just publishing a temperature value and then a callback once that's been sent. And likewise, other applications and devices can subscribe to those messages. And the way this works is very similar. So if we take a web application as an example, we can include the PubNub JavaScript SDK and then subscribe to a particular channel. And then whenever messages get published, the messages will be received by that application, so the application can respond appropriately. Now, if you don't have any real IoT-enabled devices to play with, then PubNub features a few examples on their website. One of these is called the sensor network. And this is a simulated sensor network that returns data such as this, so a temperature, radiation level, and you can use this in your application to show on a chart, just as an example. And one piece of PubNub is called PubNub blocks. And these are kind of microservices in the cloud. So these are JavaScript-based functions that run on their service, and it can execute any number of different third-party services. So whenever a message is published on a particular channel, you can take that message and maybe use SendGrid. If anyone here has heard of SendGrid before, it's a service for sending bulk emails. So you can maybe send a message as an email, or you can use IBM Watson to translate text in that message and then return it in a translated form. So let's talk about the IoT devices I have up here on stage today. The main piece of this is the Intel Edison and Grove kit. This is an IoT starter kit. It has a bunch of features, so integrated Wi-Fi. It can run custom Node.js applications. And I have multiple sensors connected to this device. So I have temperature, humidity, a motion sensor, air quality, moisture, light, UV, and then a button input. There's also a programmable LCD backlit display. So through the Node application, I can program what text I want to show on that screen, as well as control the backlight color. And then lastly, I have a USB webcam connected. So I've got a camera here pointed towards everyone in the audience. And this is a closer-up image. So this is the air quality sensor, then the moisture sensor, which can be used for detecting different levels of water, UV, light, integrated temperature and humidity, motion sensor, as well as an input button, and then finally the webcam. And this is the example of the LCD display, so I can have 2 lines of information, and then I can change the backlight color accordingly. Lastly, I have a LifeX smart bulb. This is an internet-connected LED bulb. It can support millions of colors. Some of you may have these in your home already. Just show of hands if you've... Okay, a couple of people, okay. So there's a mobile application for controlling your bulbs, so you can turn them on and off. And if you use Siri or any other IoT home service, you can speak out and say, turn on my lights. And there's a REST-based API, so more importantly, developers can control these lights from their own applications. And lastly, let's talk about some packages. So the application I'm going to demonstrate today is making use of Johnny 5. This is an incredible package that lets you interact with a variety of sensors on a wide range of different IoT devices, including the Intel Edison that I have up here today. So just go to johnny5.io. There's many examples and lots of APIs on there that you can look at. So let's talk about the application I'm going to show you today. So the app is a server room monitoring system, and the idea behind it is it's a sample application that can monitor and visualize the conditions of a server room. So it's going to use real sensor data provided by my Intel Edison, and the dashboard application that's built using Ext JS must act on this data. So if the temperature goes above a certain value, then it should have some sort of on-screen alert. I'm also going to incorporate the button as a panic alarm. So when that button is pressed, it displays an on-screen alert. And as well as that, it will flash the light bulb red a few times. The motion sensor will also issue an alert, and at the same time, it will capture an image using the connected webcam that's up here, so you can see who's in the server room that shouldn't be there. Also, the LCD display will show these alerts, so we're programmatically setting the text that's going to be shown on the screen. And as I said, the smart bulb will also visualize some of these alerts. Now, one important thing to point out with this application is there's no database behind it. All it's doing is it's using PubNub to provide data to the application. So one of the benefits with PubNub is you can store historic data. So whenever sensor data is sent to PubNub, you can choose to store that data for 7 days, 30 days, or a whole year if you wanted to. So when the application first loads up, this means you can retrieve the most recent, maybe 25 records, so the app has some data to show rather than just being a blank application. So let me just explain a bit more the setup of the application. So in the top left, we have the Intel Edison device. We have a bunch of sensors connected to this device. We have a button connected for the panic alarm, the USB webcam, and whenever an alert is fired, maybe the motion sensor or the button, the panic button, we're going to flash the LCD display red as well as show a message saying that motion was detected. And whenever a photo is captured by the device, we're going to upload that to Amazon S3. And whenever a sensor value is published or whenever an alert is fired, maybe the motion sensor or panic button, that message is being sent to PubNub. We then have the Ext JS-based dashboard in the bottom, and this is subscribing to all of these messages. And the application itself is doing some decisions. It's got some logic built in that if a sensor value exceeds a defined threshold, it's going to fire off a REST call to the LifeX API to flash the light bulb red. And likewise, because we're showing an alert on the dashboard application, we need to provide a way to reset that alarm state. So on the dashboard panels, which I'll show you shortly, there will be a reset button, and this reset button will publish a message back to PubNub, and the Intel Edison device will subscribe to that reset message. And this is the last piece. Don't worry, this looks quite complex, I know. But the last piece is there's a PubNub block, and I mentioned that PubNub blocks can be used to process these messages. So I'm using SendGrid to publish whenever a photo is captured and send that as an email to a defined email address. So as well as receiving alerts on screen, a defined user can receive the alerts via email as well as the photo. So this is a photo I took last week of the final application. So I'm using the bulb, the Edison device. And this runs across desktop, tablet, and mobile. So on desktop, we have a 4-column approach where we have all the different panels laid out nicely on screen. When you view this on tablet, because of the reduced screen space, we're reducing this down to a 2-column approach. And likewise on phone, we have a 1-column approach. So without further ado, let's jump into a demonstration, and we'll show you some of the code as well. So I've got the application running here. I'll just do a quick refresh, make sure everything's working. And every few seconds, the data is updated. So first of all, I have the moisture sensor here. So I'm just going to stick this in some water, and then hopefully we should see the moisture increase. Yeah, there you go in the top right. And again, if I take it out, it will eventually go back down. And because I defined a threshold on this sensor, you can see the alert count has increased. And if I click on that, it switches over to the alerts grid, where you can see here that the moisture sensor threshold was exceeded. So as well as just showing this data, the Ext JS application is reporting on it as well. It's capturing all of the alerts in a grid. So if I go back to the dashboard, we'll try out some of the other sensors. So here's a live feed of what I've got on screen, what I've got on the table here. So I've got a nice can of Axe body spray. I don't wear this. So I'm going to spray some of this on the air quality sensor. And if we go back to the application, we can see the air quality is really high, and it's very high pollution. And sorry for the front row if you can smell this. And again, eventually this will go back down to a reasonable level. So as well as showing the numeric data, I can also return a custom message. So the Intel Edison device, depending on the numeric value, I'm also returning a text value, so maybe low pollution, medium, or high pollution. And I'm showing that in the dashboard panel on screen. So next, let's try the panic button. So I'm going to press that. And we can see that instantly fires an alert on screen, and the dashboard application is firing the API to flash the light bulb red. Also, if I switch over to the device here, you can probably just about make out the LCD screen flashing red, although you can't quite see the text because of the brightness. But there's a reset button here, so I press this and that resets the state, and the LCD screen has gone back to a green color. Again, you can't really quite see that on the webcam, apologies for that. But one of the really cool features is the ability to capture a photo using the Intel Edison. Now I've got the motion sensor covered up with this black cloth here because the motion sensor is really sensitive. So if I just take this off, we can see that the motion sensor has activated, and what the webcam is going to do is capture a photo after a couple of seconds. So I basically send two alerts to the application. As soon as motion is detected, we send a message to PubNub, and this highlights the panel red. When the photo has been taken, which can take a few more seconds, we send through the URL of that photo. So then we can see everyone in the stage here, and we can bring that up in a full screen. And because I'm using AWS, that's the URL it's loading up. So if I switch back to the grid, I'm also making use of the exporter plugin, and this was shown off during the keynote, I believe. If we click on that, we can see all the exported alerts in Excel format, so you can do further analysis if needed. So that's the application itself. Let's jump over to some code. Now this project is on GitHub, and I'll show, let's cover up the motion sensor. So this code is all on GitHub. I've got the URL in my slides, and I'll show you that shortly. But there are two applications I have in here. I have the Node application as well as the Ext JS-based client app. So in the Node app, let's look at main.js. You can see I'm making use of the Johnny5 library. Can everyone see this okay at the back? Okay. So Johnny5 has a built-in method called board. So you're creating a new instance of the board. You're defining the input that's using. And whenever the board is ready, we can then do some stuff with the sensors and the LCD. So on my LCD screen, I have a default message that just says monitoring, and that's shown up on the screen. I then require a bunch of different sensors, and I'll show you one or two of these sensor classes shortly. I then add the sensors, which is going to set them up and also configure all those sensors to publish their data to PubNub. Then I just have a very simple timer that every second is going to update the LCD screen. And all this is doing is grabbing the current value from the sensors and just displaying the temperature and humidity on screen. And if there is an alarm, we're going to switch between a red background and a white background. So if we switch over to sensors, this is the base class that's going to hold all of the sensors. And go to sensor. This is the base class for an individual sensor like air or temperature. And what we're doing in here is we're reading a config file, so app.json, and this stores the subscribe key and publish key, which obviously I'm not going to show you. But if I go back to that file, we're also setting up properties for sensor name, frequency, so by default a sensor will publish its value every 1.5 seconds. And then we define the PubNub configuration. And whenever we call setData, what we're doing is we're comparing the previous value with the new value. If the sensor value is different, then we publish that value to PubNub through that postData method. And postData is essentially grabbing the data, tagging on a timestamp, a sensor name, and then publishing it to a particular channel. And I have a separate channel for each individual sensor. If we then switch over to moisture.js, this extends from sensor. And what we're doing is just using the Johnny5 library, we're defining the input pin. So there are various pins on the Intel Edison device that you can connect things to. So I have this connected to pin 1. We're then defining the frequency, and then we're just grabbing the value every 1.5 seconds. Likewise, if I go over to the air class, this is slightly more complex. We've got a bit more logic in here. Essentially, the air quality sensor needs some time to start up before it has a reasonable value to work from. And also, when there's very high pollution, it grabs values really quickly, so I want to throttle how often it does that. So I have two methods in here, isWarming and isTooSoon, that I can throttle and prevent too many sensor values being published. And in here as well, this is where we specify that display text that we saw on the dashboard. And then, as usual, we're just grabbing the sensor value and returning that to pubnub. Lastly, I'll show the motion class. This is more complex again because we're capturing a photo. So one of the events that you can listen for on the motion sensor is the motion start event. In here, we're capturing an image and also sending our first alert to say that motion was detected. And then in here as well, we're subscribing to that reset message. So whenever the user clicks the reset button in the dashboard, we can reset the state of that alarm. And in capture image, what we're doing is we're using the AWS SDK to upload that image, and we're using a tool called FFmpeg to control the webcam. And what we're doing is we're skipping 3 seconds, so we're allowing time for the webcam to turn on, focus, adjust the brightness, and then we're just capturing 1 frame from the webcam. So we save that to the device and then get that ready to upload to S3. So you can see here we're uploading the data. And once the image has been uploaded, we then send a subsequent message through pubnub, which is passing through the URL of where that image resides. So that's enough of the Node application. Let's switch over to the client app. And again, this code is all on GitHub, and you'll be able to have a look at this if you like later on. But one of the nice things that you can do, as I said, with the LifeX bulb is you can control it using the developer API, the REST-based API. So I have a simple class, a singleton class that I've defined that just makes it easier to flash the bulb rather than firing off an AJAX request all over my application. So in here, I've just defined a base URL. Again, the LifeX API requires a unique token, and that's stored in my app.json file. Normally, you wouldn't store this in an app.json because any client could get access to that value. So you would probably retrieve this once the user logs in, or to secure it, you might wrap the application in Electron, or for mobile, maybe PhoneGap. But I have 2 methods in here, one called pulse and one called setState. Pulse, all we're doing is we're defining the simple config for flashing a light bulb, and then we're passing that through to the REST-based API. We can also turn off the bulb through the setState method, and that's calling send request, which then does an AJAX request to the LifeX developer API. Now, if I go down to the main view, in this screen, we have our dashboard, which contains all the different dashboard panels. So you can see here the temperature gauge, which was the one in the top left corner. And then I have a bunch of value panels, and the value panel is just a very simple class I defined, which inherits from dashboard panel, which go up to here. And the dashboard panel has a bunch of properties defined on it, such as a background color. And because on the charts, on these ones here, I have a darker color and then a lighter color, I can define a left color and a right color that can be used on each of those dashboard portlets. So on main.js, for each of these panels, I'm defining the measurement that's going to be shown inside of that dashboard panel. I'm defining the max value, and this is what's used to pick up the alerts. So if the temperature exceeds the defined threshold, then we're going to store an alert in the application. Also formatting the number, so we're making it nicely formatted on screen. And then we're defining the chart min and max, so that's the y-axis, the minimum and maximum values to show. The channel that I'm subscribing to, the sensor name, and then the background colors here. Now in main controller, in my init, what I'm doing is I'm instantiating the PubNub SDK. And then further down here, I'm dynamically creating stores for each of the different sensors and then applying that onto the view model. What we then do, because this is just firing once when the application loads, what we're doing is we're grabbing historic data for each of those different sensors so that the application loads up with some basic data. So I refresh the app. It's going to go off to PubNub and get some data so we have some nice information to show the user. So that's going to get my historic data, but then I want to subscribe to any new data, and I do that through pubnub.subscribe. So in the history callback, all we're doing here is we're grabbing the data, looping through the records, and adding those sensor values to a store. And then for the final record that comes back in that result set, the last record will be the most recent value, and that's what we're showing on the right-hand side here, the current value. So we grab that last record and we're just setting view model properties that those individual dashboard panels can read from. So I think I've shown value panel already, and that's kind of a very simple structure. I've got two items in here. I've got the chart on the left, so I've got a Cartesian chart. And then on the right, I've got a container that shows the current value, as well as the toolbar, which contains the alert button itself. So to summarize what I've shown, in summary, the Internet of Things is getting bigger. There are more and more devices out there that have internet connectivity, and this means that companies need a way to show this data, make it meaningful, and provide it in some type of centralized dashboard. So more data from more sources, and in order to do anything meaningful with that data, we need a way to analyze it. And I think I demonstrated that using this Ext JS dashboard. So this type of app requires a UI that has multiple different types of components, as well as works on different types of devices. So I'm using Ext JS components very extensively. I have that D3 visualization that shows the heat map. At the moment in this application, that heat map that I showed in the bottom left is just hard-coded data. But if I tied up a backend to this and stored lots of historic data, I could very easily run a routine on the server side which would produce average values of temperatures and then show that using the D3 visualization. So using Ext JS provides us a mechanism to build a very powerful application that summarizes this type of data. And using a service like PubNub or any of the other services like the AWS or Azure IoT services, this allows you to very easily exchange data between devices as well as applications. Because this application doesn't have any direct connectivity to the Edison. All it's doing is it's subscribing to PubNub, and the device here is publishing to PubNub. There's no direct connection between the dashboard and the Edison. So I have the source code available on my GitHub, a GitHub repository. So IoT server room, my ID is Daniel Gallo, and the repo contains both the Node application as well as the Ext JS app. So if you have any comments on this later on, feel free to message me. I'd love to hear from you. Sorry, yeah, there you go. So any questions at all? Yeah.
So what's roughly the cost for all that?
So the question was, what was the cost? So the kit that I've got here, just the Edison kit, that's made by Seed Studio, and the kit I believe was around $150, $160. That came with most of the sensors. The only sensor I bought extra was the air quality sensor, and that was I think $10 or $12. No, I'm just using an HD webcam that I already had. Yeah. Any other questions at all? Yeah.
How does PubNub handle data points that came in when you were offline, like historical data points, like that you missed when?
Yes, I mean, if your device is always constantly publishing messages and your application isn't running or it's not subscribing or it's offline, then it's not going to get those values. But as long as you, inside of PubNub, inside of your account, against each particular access key, you can define how long those messages are stored for. So you can then use the history API to, when the connectivity comes back online, get those latest sensor values. Because it's all stored on PubNub, you can just get it at any time. Yeah. Any other questions? Okay.